All right, my name's Tim, and I was using Acrylate, and the process I was used or was given and assigned was the process of microsterilography of photo-based polymers. And you can kind of see through this. You have a laser that shines through. It'll then go through your neutral density filter, which will intensify your light beams, and then that gets funneled down and into the prism, and that prism will move on a planar motion in the XY plane to actually shape out your image, and then your Z stage will slowly drop your material further and further into the polymer or resin liquid, so it'll build on that first layer and then kind of slowly submerge itself, and then you'll pull your final part out from there. So the paper itself was the application of microsterilography in the development of three-dimensional cartilage regeneration scaffolds. Specifically, what they were focusing on was the adhesion of a cell called chondrocyte, and seeing how that would work given different scaffold configurations. And what chondrocyte is specifically, it is the cell that makes up the matrix of cartilage, which is later then filled in by fillers such as collagen and a couple other parts. So essentially what they wanted to focus on was how does the chondrocyte adhere to different kinds of scaffolds. And then you can kind of see the process of the current medical system on the right, where they'll actually MRI body parts that'll get thrown into a CAD model, and then they'll actually come out to a database that'll actually solve out for the scaffold type that they need. Then that'll be printed, then they'll just cut the person up and stick it in. So the material they use, the acrylate, it actually had a very complicated process to make. So they ended up taking the trimethyl carbonate and combining that with trimethyl propane. And then that had to be mixed with the 10,2 ethyl hexamate, which acted as a catalyst to actually get your reaction. And then that went through distillation and dissolving process with the dichloromethane and hexane. So they would stick it in the dichloromethane, or dichloromethane. Then they would take that precipitate, and then they'd stick it in the hexane, and then they'd re-stick it in the dichloromethane, and then do that again. And the result was a viscous liquid polymer that had photo properties to where when you shine UV light on it, it would actually harden up. So particularly, they did two types of scaffolding that they focused on for this actual test. And that was going to be a 90 and 0 degree offset of your scaffold, and then a 45 and 35 degree angle of the scaffold. So let's go ahead and look at type A. You can kind of see they're only like a couple millimeters in length on either side. So on the left you can kind of see the scaffold after they put in the chondrocyte. You don't really see too much there, but they only put about 100,000 cells, give or take, from their estimate. And then your photo on the next is 3 days, a week, 2 weeks, just to kind of let you see how much the chondrocyte actually builds up. And you can kind of see from just your after image, there's a huge difference between your original model and the following. And then for type B, you can kind of look at it and just, even your before picture, you don't really have that much. You've got a big change in the overall structure between the scaffoldings, and then you can kind of see the chondrocyte really didn't adhere much after, given 2 weeks. So then they did a calculation, or counted individually. They didn't really specify their method of counting it up, to kind of see the amount of chondrocyte that was left in the cell after their culture time. So they kind of ended it at 2 weeks, but you can kind of see in type A, you've got 4 times the amount of chondrocyte in the scaffold as compared to type B. So with that, they essentially concluded in the paper that scaffolding type does matter, which is kind of the one big takeaway from the paper. Me personally, I thought the concept was very neat and intriguing. I personally thought you kind of need to run more than just a single comparative test, given human error and other possible consequences that could have come from a test, to actually kind of get and yield that result.